Hello and welcome to this video from Heybridge Maths Department. Today we're going to have a look at problems involving length and area, and we're going to see how we can make sure we choose the right method to solve them. So our first question. In triangle ABC, the length of AC is 15 centimetres, angle ABC is 112 degrees, and angle BAC is 33 degrees. Work out the length of BC. So if I have a look at my angle of 112 degrees, I can see that that's opposite my side, which is 15 centimetres long. And then if I have a look at the side I want to find, which is BC, I can see that the angle of 33 degrees is opposite that side. So I can use the sine rule to solve this problem. So the sine rule, if you remember, is A over sine A equals B over sine B equals C over sine C. So let's substitute my values into this. So I want to find BC, so I'm going to have BC over sine 33 degrees. Now remember, you can only have sines of angles, you can't have sines or cosines or tangents of side lengths. So your side length will go where the A or the B or the C is, and your angles will go with the sine, so sine A, sine B or sine C. So I've got BC over sine 33 degrees is equal to, my side length is 15, over sine 112 degrees. Now I'm going to multiply both sides by sine 33 degrees, and that will give me BC equals 15 times sine 33 degrees all over sine 112 degrees. So the length of BC will be 8.81 centimetres to 3 significant figures. So in this question, we've got two sides. We're given that AB is 23 centimetres and AC is 20 centimetres. And we're given an angle of 55 degrees. And this is the included angle because it's the angle formed where AB and AC meet. And we're asked to find BC. So in this case, where we've got two sides and the included angle, and we're asked to find the length of the third side, we're going to use the sine rule. So just as a reminder, the sine rule is A squared equals B squared plus C squared minus 2BC cos A. Now remember that A is always the length of the side opposite the angle that you know. It doesn't matter which of the other two sides you choose to be B and C. B and C are just the two sides that include the angle. So I'm going to substitute my values in. So I'm going to have BC squared equals 23 squared plus 20 squared minus 2 lots of B, so that's 23, times C, which is 20, times cos 55 degrees. So that means that BC squared will be equal to 929 minus 920 cos 55 degrees. So BC will be equal to the square root of 929 minus 920 cos 55 degrees. And if you pop that into your calculator, you will get that BC is equal to 20.0 centimetres to 3 significant figures. Now, this time we're being asked to calculate the area of a triangle. And we've got two sides, we're given 6 centimetres and 7 centimetres, and we've got an included angle of 60 degrees. Now we can't use half base times height here because we're not given a perpendicular height for this triangle. So we need to use the sine rule for area. So we're going to use area equals half AB sine C. And again, A and B are just the two sides that include the angle. It doesn't matter which one you choose to be A and B, but you must make sure that C is your angle, because as we said earlier, you cannot have a sine of your sides. So the area of this triangle is going to be half times 6 times 7 times sine 60 degrees. Now you do need to know some exact trig ratios, and sine 60 degrees, the exact value of that is root 3 over 2. So you could use that in your calculation. So you could say that area is equal to half times 6 times 7 times root 3 over 2. That would give you 42 root 3 over 4. And then if we simplify that, we'll get 21 root 3 over 2, and it's an area, so we need to remember to include units, centimetres squared. If you come up against this on a calculator paper, you may decide not to use the exact value, or you may be asked to give your answer to a certain number of decimal places or significant figures, in which case you would use your calculator. And your answer to 3 significant figures would be 18.2 centimetres squared. So you would use this exact value if you were asked to find the exact value on a non-calculator paper, and you could use your calculator and give your answer to a number of decimal places or significant figures if this question appeared on a calculator paper. Right, so the diagram shows two vertical posts, AB and CD, on horizontal ground. So if these are on horizontal ground and they're vertical posts, we know that we're going to have two right angles there. So let's put those on. AB equals 1.7 centimetres, CD to AB is 1.5 to 1, and the angle of elevation of C from A is 52 degrees. Calculate the length of BD and give your answer correct to 3 significant figures. So we know that CD to AB is 1.5 to 1. So CD will be 1.5 times greater than AB. So CD will be 1.7, which is the length of AB, multiplied by 1.5. That will give us 2.55 metres. So we know that the height of CD is 2.55 metres. We're also given that the angle of elevation of C from A is 52 degrees. So if I were to draw a horizontal line along here, so I'm going to have a right angle here, right angle here, right angle here, join C and D up, this angle is going to be 52 degrees. That's the angle that C is above the line of sight, or the horizontal for A. So I can use trigonometric ratios to solve this, but I need to know the length of this section here. So let's label this point here B. So to find CE, I'm going to need to take, well, ED and AB are parallel and equal. So I'm going to need to do my 2.55 and I'm going to take away 1.7. So that's going to give me 0.85 metres. So CE will be 0.85 metres. Now if I have a look at my angle of 52 degrees, so AE is parallel and equal to BD. So if I find AE, that will be the same as the length of BD. So AE is adjacent to my 52 degrees and CE is opposite. So I've got opposite and adjacent, so I'm going to use the tangent ratio. So I'm going to say that tan 52 degrees is equal to opposite, which is 0.85, over adjacent, which is AE. So rearranging, I will get AE equals 0.85 over tan 52 degrees, and I'm asked to give my answer correct to 3 significant figures. So that will give me 0.664 metres. So BD to 3 significant figures is equal to 0.664 metres. So our next question, ACD is a triangle and B is a point on AC. AB equals 8 centimetres and BC is 6 centimetres. Angle BCD is 48 degrees and angle BDC is 50 degrees. Find the length of BD. So looking at this, straight away I can see I've got angle BDC is opposite 6 centimetres and my angle of 48 degrees is opposite the side that I want to find. So I can immediately use the sine rule to find BD. So BD over sine 48 degrees, because 48 degrees is the angle opposite BD, will be equal to 6 over sine 50 degrees. And then rearranging that, I'm going to get that BD will be equal to 6 times sine 48 degrees all over sine 50 degrees. So BD is 5.820640033 centimetres. Now you can round that, let's round that to 5.82 centimetres. You do need to keep this full answer, this 5.820, etc. answer, because you're going to need to use it in later parts of this question, and you mustn't use a rounded answer for another part of the question. You must always use the full value. So we're now asked to find the length of AD. So I know what BD is now. This is 5.82 blah blah blah. I can find angle DBC by doing 180 minus 50 minus 48, which will give me 82 degrees. So that will be angle CBD. I actually want to know angle ABD. So I can do that by doing 180 minus 82 degrees, which will give me 98 degrees. I can now use the cosine rule to find the length of AD. So let's do AD squared is equal to 8 squared plus you will need to put the whole of that value in. I've just put the ellipsis there to show that the number carries on, minus 2 lots of 8 times 5.820 cos 98 degrees. And then we pop that into the calculator and we get AD as being equal to 10.52810.879 centimetres, which we can write to 3 significant figures as 10.5 centimetres. Now our final question is to find the area of triangle ABD. So we're going to use the sine rule for area. So we've got an angle of 98 degrees here, and we've got a length of 8 centimetres and another length of 5.820, 640033 centimetres here, which enclose the angle. So the area is going to be half times 8 times the whole of that value that you calculated in part A times sine 98 degrees. And that will equal 23.1 centimetres squared to 3 significant figures. And you can round that answer. So you can round the answers that you actually put in the answer spaces, but if the question continues with more parts, you must keep those full values and use them in those parts of the questions. So here we're asked to find the size of angle XZY, and we're given the lengths of our 3 sides. Now, if we're given the lengths of 3 sides of the triangle, and it's not a right-angled triangle, and we're asked to find an angle, we need to rearrange the cosine rule to do this. So if you remember, your cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So the first thing that I'm going to do is I'm going to add 2bc cos a to both sides so that I've not got any nasty negatives. So I'm going to have 2bc cos a plus a squared equals b squared plus c squared. Then I'm going to subtract my a squared from both sides. So I will get 2bc cos a equals b squared plus c squared minus a squared. Then finally I'm going to divide by 2bc. So I will get cos a equals b squared plus c squared minus a squared all over 2bc. And that's the form of the cosine rule that we use when we need to find a missing angle. Now you must remember that this angle is A, so A will be the side opposite little a. It doesn't matter which of the other 2 sides you choose to be B and C. So we're going to have cos A equals 20 squared plus 22 squared minus a squared, which will be 17 squared, all over 2 lots of BC, so 2 lots of 20 times 22. And if I pop that into the calculator, that's going to give me 119 over 76. So cos A is equal to 119 over 76. I now need to take the trig inverse of that, so the cosine inverse. So A will be equal to cos to the minus 1, 119 over 76. And that will give you, to three significant figures, 47.5 degrees. So question 7 is to calculate the size of angle ABD. So that's going to be that angle there. So the first thing that I'm going to do is to calculate the length of BD, because looking at this, I can see that I can work out BD using the two angles and the length that I'm given in triangle BCD and the sine rule. Once I've got BD, I can then use the rearranged form of the cosine rule to work out angle ABD. So first of all, I'm going to use the sine rule to find BD. So BD is opposite 50 and 68 is opposite 8.4. So I'm going to have BD over sine 50 degrees is equal to 8.4 over sine 68 degrees. And if I rearrange that, I will get BD is equal to 8.4 multiplied by sine 50 degrees over sine 68 degrees. And I want to keep the full length of BD for my next part of working to make sure that my answer is really accurate. So BD will be 6.940126589 centimetres. Now I'm going to use the rearranged form of the cosine rule that we found in the previous slide. So if you want to go back and have a look at that, that's absolutely fine. So I'm going to have cos ABD, the angle that I'm trying to find, is equal to 6.5 squared plus BD squared, so 6.94 etc. squared, minus the side that's opposite the angle that we're trying to find, minus 5 squared, all over 2 lots of 6.5 times that full value of BD that you found earlier. So that will give you cos ABD as being equal to 0.7250 516 946. And then we're going to take the inverse. So we're going to do ABD is equal to cos to the minus 1 of that number from above so ABD is equal to 43.5 degrees to three significant figures. So the next question, two small boats are 24 metres apart. The angle of elevation of the boats to the top of the lighthouse are 20 degrees and 34 degrees respectively. Calculate the height of the lighthouse. So the first thing that I'm going to do is I'm going to work out the missing angles in the left-hand triangle. So angles that are next to each other on a straight line add up to 180 degrees. So that's going to be 146 degrees. Angles in a triangle sum to 180 degrees. So that angle is going to be 14 degrees. And now I can find this length here. So I'm going to find this length here. So if I have a look, I've got my angle of 14 degrees is opposite my side of 24 meters. My angle of 20 degrees is opposite the side that I want to find. So I can use the sine rule. So I can do BC. Let's just label this. So let's have A, B, and C. So if we say that BC over sine 20 degrees is equal to 24 over sine 14 degrees. And let's rearrange that. So we're going to get BC is equal to 24 sine 20 degrees over sine 14 degrees. And that's going to give us BC as equal to 33.93030.391 meters. I'm going to use that in the next part. So H would actually be at right angles. So if this were H, that would actually be at right angles there. Because the surface of the water is taken to be horizontal and the lighthouse is taken to be vertical. So we know this highlighted side now. So we can now use trigonometric ratios to work out the height of the lighthouse. So BC is the hypotenuse of the right angled triangle. So we know we're going to need to use the hypotenuse. And the height, the lighthouse, is opposite 34 degrees. So we're going to use the sine ratio. So we're going to say that sine 34 degrees is equal to, the opposite is little h, so little h over our hypotenuse, which is 33.930. So the full answer from above. So if we rearrange, we're going to get h is equal to 33.930 multiplied by sine 34 degrees. So that will give us h as being equal to 19.0 meters to 3 significant figures. Now we're going to have a look at a nice bearings question. So ship A is 50 kilometers from X on a bearing of 258 degrees, and ship B is 44 kilometers from X on a bearing of 312 degrees. Calculate the distance between A and B. So ship A is 50 kilometers from X and ship B is 44 kilometers from X. Ship A is on a bearing of 258 degrees. Ship B is on a bearing of 312 degrees. So this angle here, BXA, we can work that out by finding the difference between the bearing of A and the bearing of B. So angle BXA will be equal to 312 degrees minus 258 degrees, which will give us 54 degrees. So this angle here is 54 degrees. And now we've got a nice simple problem that we can solve using the cosine rule. So we want to find AB. So AB squared will be equal to 44 squared plus 50 squared minus 2 lots of 50 times 44 cos 54 degrees. So AB squared will be equal to 4,436 minus 4,400 cos 54 degrees. So therefore AB will be the square root of that. So AB will be the square root of 436 minus 4,400 cos 54 degrees. So AB will be 43.0 kilometres to 3 significant figures. So the distance between A and B is 43.0 kilometres to 3 significant figures. So our final question, ABC is a quadrilateral. AB is equal to 8 centimetres, AD is equal to 15 centimetres and CD is 12 centimetres. Angle ADC is 78 degrees and angle BAC is 20 degrees. So they've marked the sides on for us, but they've not marked the angles. So the first thing that I'm going to do is to mark these angles on so that I can see what I'm going to do. So that's going to be 78 degrees, that one's BAC, that will be 20 degrees. And my first task is to calculate the length of AC. So I'm going to use triangle ADC to do it. I've got an angle, I've got two sides and an enclosed angle, so I'm going to use the cosine rule. So let's go with AC squared will be equal to 15 squared plus 12 squared minus 2 lots of 15 times 12 times cos 78 degrees. So that's going to give me that AC is equal to the square root of 369 minus 360 cos 78 degrees. So AC is going to be 17.15085,395 centimetres, and that would be 17.2 centimetres to 3 significant figures. Question B, calculate the area of the triangle ABC. So we now know the length of side AC. So again, we've got two sides and the enclosed angle, so we can use the sine rule for area. So we can say that area is equal to half times 8 times the full answer that we got for question A multiplied by sine 20 degrees, and that will give us 23.5 centimetres squared to 3 significant figures. Thank you for watching.